Let's deal with domains. We have roughly dealt with all of the three, which is your x and y intercept, your graphs, your interpretations of graph. We still gonna deal with more graph and interpretation. Okay, for now let's talk with domain and range. Okay, what is the range? Oh, and what is the domain? Okay, let me draw a graph for you to make this example clear. Okay, and the simple way to determine this is to go straight to the graph. Even if it is not given, you must plot yourself a graph in order to get that 2 marks. Okay. Um, range. Let's start with range. It's more simple. Range refers to the y values, refers to the entire line here. All right, that is our range. It refers to the entire line here, but relative to the graph, it refers to the entire values of y and this line, but relative to the graph, meaning limited to the graph. I will explain what do I mean by that. Okay, if we have a straight line graph like this, and we're asked if what is the range of this graph. This graph, in terms of y axis, is continuous in the positive side. We can't say this graph is gonna end anywhere here. You see, it's continuous, meaning in terms of the positive side, it's infinite. And in terms of the negative side, it's also infinite, because we can't tell where is the graph gonna stop here. It's continuous, because this arrow, it means that it doesn't end. It's going downwards forever. So the range, I mean the range in this case is gonna be negative, infinite, and positive, infinite. So those are your values. That is your range. You are done. What about domain? Domain refers to x. It's only speak to x. Only x. You only consider x. The same thing. In terms of x positive direction, where is the graph gonna end? We can't tell. It's continuous. It's moving always to that direction. We can't tell where is the graph gonna end, meaning we already have a positive infinite in terms of x-axis. Where is the graph gonna end in terms of x-axis? We can't tell. It's continuous, meaning we already have a negative infinite again. So for x, our domain is gonna be a negative, infinite, and positive infinite. Another way of writing this, we would just say y is an element of all real numbers, because all the y values are included. Another way of writing this, we're gonna say x is an element of all real numbers. You can just write this and you got your full marks. Okay, what about where you have a parabola graph like this? A parabola graph like this. What is our domain? When I have a horizontal test like this, do I cut that graph here? No, of course not. I don't cut that graph, meaning this graph doesn't come here, it ends there. If I come here, I cut the graph. If I come here, I cut the graph, meaning going upwards, the graph doesn't end. What does that mean? I can say, okay, y is equal to 0, because y touches 0 here. It starts at 0. I can say y is equal to 0. But does it end only on 0? No, it's also go above 0. That means I can say y is greater or equal to, it's equal and above 0. So that is our range in that case. That is our range. Is there any changes in terms of domain? What about domain? Does this graph end in anywhere here? No. I'm gonna cut this graph all over here because it's an arrow there. It's going all the way up to whatever positive value, maybe 2000 or 100 billions. What about the negative sign? It's the same thing, meaning I'm still having the same answer for domain. There's no change in domain. I'm still having the same answer. It's negative infinite and positive infinite because the answer doesn't end in both end. All right, so you can simply say x is an element of all real numbers where the graph doesn't end in either side, doesn't have a limit. Okay, in this case it's limited to 0. It doesn't go below 0, so 0 is a limit in that case. So your answer will look like that. Y for a range, y is gonna be equals to 0 and greater than 0. All right, so that is what we call range. All right. What about a situation where we have, what about a situation where we have an exponential graph. Exponential graph normally looks like this. Let's say this is what is g of x. What about that case? Do you see about this graph? This is an asymptote. In this case, it's horizontal asymptote. This graph will never touch 0, unlike here. Here we had 0 on the graph, but here this graph will never touch 0. So what does that mean? For range, it means that whatever value that is greater than 0 is part of that graph, but whatever value from 0 going downwards is not part of that graph. How do we write that as an answer? We simply say, in this case, y must be greater than 0 because it's not 0, it's not less than 0, but it's more than 0. So that is our answer, that is our range. Another question will be, what about domain? Does this graph have any limits this side? No. So we have already positive infinite. Does this graph have any limit this side? No. It's going all the way up to whatever negative a number. So we also have negative infinite. Okay. So you can say x is an element of all real numbers. Okay. Let me illustrate another point. Okay, I will deal with other point and the graphs at a later stage, or with other graph at a later stage. Let's go back to here. I'm trying to interpret the graph now. Let's come back here. When they are okay, we can do it here. We can do it over here. Let's say I'm having a graph of this nation. Okay. And another graph of this nation. Okay. I'm having A. Oh, A tend to be here most of the time. And A, let's say this is C. Okay. For whatever reason. This is D. This is E. G. What else here? F. Okay. We can have, let's say it's Asia. Okay, this is a beautiful graph. Okay, x-axis and y-axis. Okay, so if they are asking, let me have very here. Let's say it's 3, this is 2, and this is negative 2. And what if they're asking the distance between A and B? What is the distance between A and D? What is the distance between A and D? Okay, these are the coordinate 3 and 0. Some would normally like to use distance formula, but in this case, if the distance is along the x-axis or the y-axis, I don't need to use distance formula for that one. What I would say, I would ignore this negative sign and simply say the distance between A and B is simply 3 plus 2, which is equal to 5. How do we know that it's true? Okay, let's check it. From here to here, you go how many units? It's 2 units. From here to here, how many units? It's another 3. It's 3 units. So the distance from here to that point has to be 5 because you have 2 units here, 3 units here, but the total distance has to be 5. Hence, we are having 5 as a distance. All right. Okay, let's say we have 5 here. If they are asking, let's say we are having -3. The same question here. We have 5 there, they have 3 here. They're asking the distance between F and G. What is the distance? This is along with y-axis, along y-axis. So why would I bother with distance formula? I don't need to use distance formula. I don't have time for that. What do I do? Okay. What is the distance from here to here? It's 3 units. I go 3 units from here to the point of origin. From here to this point, which is G, how many units? It's 5 units, but the total distance from F to G has to be 8. It's 3 plus 5 has to be 8 units. All right, has to be 8 units, as you can see. Okay. What if they're asking, this is not along, if they're asking the distance between E, which is this point, and this point, on that case, I need to first, because they are indirect, asking the coordinate of H. How do I get first the coordinate here? Because I can't use that logic. It's not along y-axis or x-axis, so I can't use that logic anymore. I'm forced to use distance formula here, but I need to know the coordinate here. How do I get them? But what I know is the intersection of the two graphs, which is this graph and this graph. But what does that mean? It means that they are sharing exact same values here. They are equal here. So that means this graph is equal to this one. If this is f of x and this is g, I would say f of x is equal to g of x, and substitute with its equation and solve for x, after which I would then take those values of x and substitute to the original equation in order to get corresponding y values, so that I can get values here and values there. Because remember, they are intersecting in 2 parts, meaning we have 2 points, but you have to choose which one to use, because you can't use a positive x value of which you are at H. All right, you have to choose y's at this point. All right, then you need to determine a turning point there. Maybe it can be 8 marks. I think you need also to determine a turning point, as we said. Then you use the coordinate here and the coordinate here to use a distance formula. Okay, if they are asking you about this, what is the coordinate of this one, it's gonna be 5. It's 0 to 5. If 5 is not given, you go straight to the equation of this line, because this is y-intercept, where you see c. The c in that case is gonna be exactly your value. All right. Even here is your y-intercept. You go straight to your original equation of this one. If 3 is not here, and you check for C. C is gonna be your coordinate of F. All right. For this and this, you have to determine your x-axis, because this is at x and this is at x, and they are x-axis, x-intercept, I mean x-intercept of parabola. So you have to use that graph. I will explain on the other video, I think, for more clarity.